provided by Thomas Elgire and Frennis, based on the most relevant LinkedIn posts about connected tools and equipment in calendar weeks 31 and 32. Frennis is a B2B market research company that supports enterprises in the power tools sector with building feature-by-feature competitive intelligence that shows exactly how their product stacks up against the competition. You can find more info in the description.
Imagine dropping a heavy digital wrench on a solid concrete floor. It doesn't shatter. The screen, it still turns right on.
Right.
So you pick it up, you brush it off, and you go right back to work on a multi-million-dollar engine assembly line.
Makes sense. It looks fine.
Exactly. But then, 4 months later, that single dropped wrench costs your company millions of dollars and a massive, catastrophic product recall. Today, we're looking at exactly why that happens and, how the industry is actively trying to stop it.
Yeah, and if you are a smart build or manufacturing professional, you know that keeping track of your physical assets is, well, it's arguably the most complex part of your operation.
Oh, without a doubt.
So today, we are cutting through all the marketing noise to map out the actual state of connected tools and equipment. The mission for this deep dive is simple. We're going to unpack the fundamental shifts in how tools are tracked, how they deliver precision, how they're powered, and how they actually survive the chaos of a job site.
I love it.
Okay, let's unpack this, the whole concept of asset tracking. Because for a massive number of organizations, asset tracking is treated purely as an end-of-year compliance exercise.
Which honestly completely misses the point of the technology.
It really does. A post from Dan C. really hammered this home. He pointed out that asset tagging is, fundamentally misunderstood in facilities management right now.
How so?
Well, people just assume that sticking a QR code or an RFID tag on a piece of equipment is the finish line. They do it to satisfy an auditor.
Right, checking a box.
Yeah, exactly. But a tag, without an operational data framework behind it, is basically just a very expensive piece of tape. I mean, if that tag doesn't immediately pull up the tool's maintenance history, its remaining useful life, and its total cost of ownership, you are flying totally blind.
Yeah, you just end up with reactive maintenance.
And you're purchasing duplicate assets just because you can't locate the ones you already own.
It is exactly like having a check engine light on your dashboard, but no OBD scanner to actually read the diagnostic codes.
Oh, that's a great way to put it.
Right. The light tells you something exists in a state of error, but it gives you zero diagnostic power to actually fix it. So to solve this, companies really have to move beyond those static labels and start mapping spatial data in real time.
But a modern job site or a warehouse is a total nightmare for wireless signals. I mean, you have metal racks, bouncing frequencies everywhere, moving robots, heavy machinery causing electromagnetic interference.
It's a mess.
So how do you actually pinpoint a tool's location in that kind of chaotic environment?
Yeah.
Because a standard Bluetooth beacon is just going to bounce off a metal I-beam and, tell you the tool is 3 rooms away.
And that is exactly where the hardware is evolving in some really brilliant ways. Michael Spurk has been documenting his testing with Bluetooth channel sounding.
Okay, what is that?
Well, instead of just measuring signal strength, which is what gets confused by all those metal reflections, this system uses dual antennas on the tags.
Oh, interesting.
Yeah, they measure the precise time of flight of the radio waves as they bounce between multiple antenna paths.
So it's timing the bounce, not just looking at how loud the signal is.
Exactly. By calculating exactly how long the signal takes to travel, the system can basically filter out all those chaotic reflections and achieve sub-1 meter accuracy.
Wait, really? Sub-1 meter in a metal warehouse?
Yeah, it's wild. You are essentially building a highly accurate, location-aware industrial geofence. You don't just know the tool is somewhere in the building. You know it is on rack 3, shelf B.
That level of spatial awareness completely rewrites the workflow for the people on the floor. Take layout tasks, for example. Yafed G. Sanchez Ruelas broke down the classic construction trade-off, which is speed versus millimeter accuracy.
Right, it's usually one or the other.
Historically, layout required 2 people, a tape measure, string lines, and, a lot of manual trigonometry. If you wanted it perfect, it took all day. But Hilti is trying to bypass that manual bottleneck entirely with their layout platform.
What's the setup look like?
It's basically a triad. You've got a motorized total station, a rugged tablet, and a self-leveling laser accessory.
Right, and the mechanism there is what makes it so disruptive. The software on the tablet actually pulls the 3D BIM data, the digital blueprint, directly into the physical field.
Yeah, it bridges the gap.
Exactly.
Yeah.
The total station uses lasers to triangulate the exact position of the worker holding the accessory, and then motorized drives automatically guide the laser to the precise digital coordinate right on the concrete floor.
Which is a massive time saver.
It's huge. One person goes from painstakingly plotting 150 points a day to knocking out over 500.
And we are seeing that visual mapping push even further into augmented reality, too. John and Martinez Munoz showcased a prototype for a wall scanner XR.
Oh, the XR stuff is fascinating.
Yeah, think about how a traditional stud finder works. You slide it over the drywall, it beeps, you make a tiny pencil mark, and then you have to remember what that mark means. It's a totally isolated reading.
Right, and easy to mess up.
Exactly. But the XR prototype pairs with AR glasses. So as you scan the wall, it anchors its readings directly onto the physical surface in your field of vision. It builds a persistent 3D spatial map of the pipes, the studs, the wires inside the wall, and it stays visible as you walk around.
The reduction in human error there is just massive. But, I mean, getting that kind of technology onto a worker's head is a pretty heavy lift for the balance sheet.
Oh, for sure.
Mark Elshai actually did a breakdown of high-tech PPE costs. If you want to outfit the worker of the future, and we are talking a powered exoskeleton for lifting, a smart helmet with AR overlay, and a rugged tablet, you are looking at an investment of $13,000 to $18,000 per person.
Wait, 18 grand to outfit one single worker?
Yeah.
You are going to have a near impossible time getting a procurement manager to sign off on that for a crew of 50 unless there's an absolute bulletproof guarantee of a return. I mean, that is a massive capital expenditure.
It definitely sounds prohibitive until you look at the mechanics of the return on investment. Take the exoskeleton, for example, which leases for about $300 a month.
Okay.
What that suit actually does is shift the mechanical load of lifting away from the vulnerable lumbar spine and disperse it down through the legs.
Wow.
And if you are doing overhead work, it actively supports the arms. So the worker's fatigue doesn't just spike at 2:00 p.m. They maintain their morning efficiency for the entire shift.
So they're just getting more done more safely.
Exactly. You recover that $300 loose in the first 5 days just through sustained productivity alone.
Let alone avoiding a blown-out disc that could cost a company upwards of $40,000 in medical and lost time expenses.
Exactly. Or, look at the smart hard hat. Say a superintendent is walking a floor before a massive concrete pour. The AR visor overlays the BIM model in real time, and they instantly see that a plumbing sleeve was framed like 3 inches off its target.
Which is a disaster if you pour the concrete.
Right, because fixing that single MEP conflict later requires jackhammers, structural engineers, and weeks of delay. Catching it before the pour saves $20,000 in rework instantly. What's fascinating here is that the physical hardware, the helmet, the scanner, is becoming completely secondary to the software ecosystem and the predictive data it unlocks.
But, knowing where a tool is or mapping a space, that really only solves half the accountability problem. The other half is knowing what that tool actually did once it got there. If spatial data prevents costly rework, calibration data prevents catastrophic failure. And right now, the industry is dealing with a major systemic issue when it comes to bolting precision.
Because the pressure of project timelines heavily incentivizes crews to prioritize speed over exact specifications. Jerry Sharp actually issued a fantastic warning about the impact driver problem.
Yes, specifically regarding rain screen cladding systems, right?
Exactly. Installers absolutely love impact drivers. I mean, they are lightweight, fast, and require almost no physical exertion from the user. But mechanically, they deliver violent, repeated rotational strikes.
Which is a complete disaster for soft metals.
Yeah.
When you're assembling aluminum support rails and brackets, the manufacturer engineers those components for a highly specific controlled torque. The aluminum can only handle so much clamping force before it microfractures. So when an installer hits it with an impact driver, they aren't just tightening the bolt. They are easily stripping threads, deforming the aluminum, and completely voiding the $1 million system warranty in a fraction of a second. The tool is fast, but it is fundamentally the wrong mechanism for the material.
But here's the thing. If using the wrong tool is a structural disaster, what happens when you use the correct tool? But your calibration process is based on just a blind calendar date.
You just get a false sense of security.
Exactly. Daniel Krauss shared a perfect example of this seasonal calibration trap. A manufacturing facility set a flat 12-month calibration interval for every single torque wrench on their floor. For 3 years, the records were totally clean.
Okay, sounds good so far.
Right. But then one specific wrench suddenly drifted 9% off target on a fastener spec that only allowed a 4% variance.
Oh man, and a 9% variance on a critical joint is literally the difference between a machine running smoothly and a machine vibrating itself to pieces. What caused the sudden drift?
Thermal expansion. That specific wrench sat on a workstation about 8 feet from a paint cure oven.
Oh, I see where this is going.
Yeah, when Krauss plotted 5 years of calibration history against the calendar months they were tested, an undeniable pattern emerged. Every single failed or borderline reading happened in July or August. Every clean reading happened in November or February.
Because of the ambient heat?
Exactly. During the summer, that paint booth ran 40 degrees hotter than the rest of the floor. The ambient heat was literally warping the internal gauge mechanism of the wrench.
Wow.
They solved it by simply moving that specific workstation to a 6-month calibration interval during the summer stretch.
A calibration interval that is set once and never verified against environmental reality is just a guess wearing a certificate. Which, brings us right back to the scenario we opened the show with.
Right, the dropped wrench.
Yeah, Sean Guinane detailed how this plays out in high-stakes environments. A company building high-value engines had an operator drop a digital torque wrench. And because the screen didn't crack and it still gave a digital readout, the operator just picked it up and kept using it.
But the internal load cell was knocked out of alignment, causing it to read high.
Meaning every single bolt it touched after the drop felt tight to the wrench but was actually left under-tightened on the engine block.
Yikes.
4 months later, an engineer grabbed that wrench, noticed the physical resistance felt incredibly soft for what the digital readout said, and put it on a tester. It failed miserably.
But because they only calibrated annually.
Exactly. They had zero data to prove exactly when the wrench went bad, and they had to assume it happened the day after its last official calibration. They were forced to recall 4 months of engines costing millions.
That is brutal.
Now, they mandate that every wrench on the line is validated weekly against a digital tester, because the absolute maximum risk they are willing to absorb is 1 week of production.
And this exact vulnerability is why we are seeing a massive push to hardwire torque tools directly into manufacturing execution systems, or MES. Peter Chu highlighted how the Stahl-Will Daptq 766 torque wrench operates in a Taiwanese high-tech manufacturing plant.
How does that work?
Well, the wrench is integrated wirelessly into the MES. When a worker scans a work order, the system sends the exact torque and angle requirements straight to the tool.
So the worker doesn't even have to set the wrench. The system just locks it in.
Precisely. As the operator pulls the wrench, the torque and angle results are captured in real time and permanently linked to that specific engine's serial number. It is a closed loop of accountability.
That's incredibly smart.
Yeah, if the operator pulls short, the system flags the abnormal result instantly and locks out the next step on the assembly line until it's corrected. There's no manual data entry, no missing records, and definitely no pencil whipping the inspection forms.
Now, before we move on to how these smart tools are actually getting their power, if you are finding these breakdowns valuable for your own operations, make sure you subscribe to the show so you don't miss our upcoming deep dives. It is honestly the easiest way to stay ahead of the curve in industrial tech.
Absolutely. So if MES integration requires tools to be smart and mobile, you really can't have operators tripping over pneumatic airlines or heavy extension cords. The demand for digital accountability is directly driving the evolution of battery architecture.
Yeah, and the battery tech is fundamentally changing what cordless tools can physically do. Ethan Huff broke down Makita's new 40-volt max tables battery technology, and the physics here are just fascinating.
I was reading about this.
Yeah, so inside a traditional lithium-ion cell, you have these small metal tabs that connect the internal foil layers to the external terminals. All the electricity basically has to funnel through those tiny metal tabs. It's like forcing 6 lanes of highway traffic through a single toll booth.
Right, which creates a massive bottleneck.
Exactly.
Yeah.
Which generates internal resistance, and that manifests as heat.
And heat is the absolute enemy of a lithium-ion battery. If it gets too hot, the tool's computer just shuts it down to prevent a fire.
Exactly. So Makita completely removed those internal tabs.
Yeah.
By altering the cell design, the entire edge of the anode and cathode foil acts as the connection point. You remove the toll booth entirely.
Wow.
Current flows instantly across a massive surface area. You get higher sustained power output, significantly less heat buildup, and the ability to drive massive bursts of energy into heavy-duty applications without the tool thermal faulting.
And that thermal management is the key that unlocked heavy industry for battery platforms. Tasks that used to absolutely require a massive diesel air compressor are going cordless now.
Like what?
Well, Todd Warhurst pointed out the BR Extreme battery torque tool. This unit delivers 5,000 foot-pounds of torque.
5,000, that's insane.
Yeah, it is. It's actively replacing aging pneumatic fleets in mill relining operations. If you picture a mill, it is a massive, confined, dirty cylinder. Dragging heavy pneumatic hoses into that space is a huge tripping hazard and a logistical nightmare. The battery tool does the exact same job, faster and lighter, without the hose.
We're even seeing it in high-speed applications. Pelayo Campomani Sanchez highlighted the Bosch EXN H18V90 cordless nailer.
Oh, the nailers are getting so good.
Yeah, historically battery nailers were slow because a motor had to physically wind back a heavy spring for every single shot. But this Bosch unit matches pneumatic speed. It fires 3 nails per second.
How are they getting it that fast?
It uses built-in air spring. So there's a sealed cylinder of compressed gas inside the tool. The battery motor simply compresses and releases that captive air instantly for every shot. And it has a built-in Schrader valve so you can easily top off the internal pressure. You get the explosive speed of a pneumatic nailer, but you leave the heavy compressor in the truck.
So what does this all mean for the business strategies of the major manufacturers? When a battery platform becomes capable of running everything from a small drill to a 5,000 foot-pound torque wrench, the brand ecosystem becomes incredibly sticky for the end user.
Oh, totally.
Christian Reed made a really sharp observation about how companies are approaching this. You have Milwaukee Tool, who keeps almost all their engineering strictly in-house. They focus heavily on dominating highly specific niche trades.
Right. Christian Bruscher actually mentioned their M18 fuel cable stripper, which is designed to solve one very specific, highly repetitive pain point for commercial electricians.
Exactly. Whereas DeWalt is taking a completely different avenue. They are leaning hard into strategic partnerships. They team up with companies like August Robotics for automated concrete drilling or Grabo for heavy-duty suction tools.
That makes a lot of sense.
Yeah, DeWalt knows they have massive global distribution and undeniable brand power. Instead of spending years engineering a niche robotics tool from scratch, they partner with the experts and bring those innovations to a massive market through their existing battery ecosystem.
Both are brilliant strategies because the end goal is exactly the same. Lock the contractor into the battery platform. Banu Deniz Kintukol and Elston Lin both discussed the rollout of Hilti's Neuron platform.
And what are they finding?
What customers are discovering is that standardizing on a single battery architecture simplifies fleet management to a degree that actually moves the needle on profitability. There's no more searching for the right charger or matching voltage to the tool. They're reporting job site productivity lifts of up to 25% just by eliminating the logistical friction of mixed power sources. We are well past the point of cordless being a compromise.
But let's ground this in reality for a second. All the tabless battery architecture, MES integration, and Bluetooth tracking in the world means absolutely nothing if the physical casing shatters the first time it falls off the scaffold. Or worse, if the tool the worker is relying on isn't even real.
Yeah, the counterfeit issue is wild. The human element of brand trust is still the ultimate filter for all this technology. Bello Gideon shared a really revealing experience from running a Bosch service clinic at the Okanagan market.
What happened?
Local craftsmen were bringing in their broken tools for repair, genuinely believing they had invested in original Bosch products. The service team had to sit them down and explain that the tools were actually sophisticated counterfeits.
Which is just devastating. I mean, these craftsmen are making purchasing decisions based on price pressure, but they are buying into the promise of a premium brand's durability.
Exactly.
When that counterfeit tool breaks, it doesn't just halt their livelihood, it actively destroys the trust in the marketplace. After-sales service isn't just about swapping out a broken motor, it is frontline market education.
And if a brand wants to maintain that trust, they have to engineer for an environment that actively tries to destroy equipment. Benna K. Earhart raised a highly provocative point, comparing construction tools to the automotive industry.
Oh, this is a great comparison.
Yeah, construction tools are fundamentally engineered to outlast careers. They survive concrete dust, freezing rain, being dropped in mud, and daily mechanical abuse. They are designed to be opened up, serviced, and handed down to the next apprentice.
I would push back slightly on modern EVs being completely disposable, but his broader point definitely stands. Many modern cars, especially early electric vehicles, feel like sealed consumer electronics.
Right. You can't service them yourself. The software ages out incredibly fast, and they suffer from planned obsolescence dressed up as innovation.
Automotive design could absolutely learn from the construction philosophy of building industrial mechanisms designed for decade-long life cycles.
Because professionals who work with their hands have zero patience for marketing hype. Pat Pitchell shared that Stanley launched a new global platform with the tagline, "All build, no bull."
I like that.
You don't earn trust on a job site with loud claims on a billboard. You earn it by respecting the harsh physical realities of the people who rely on your engineering to feed their families.
If we connect this to the bigger picture, durability is really the truest form of sustainability. Alexander McAfee noted how Hilti equipment survives in underground mining environments. A tool that can take a beating in a mine for 10 years is infinitely more sustainable than a cheap tool that burns out its motor and ends up in a landfill after 2 years.
True sustainability starts with the intention of the engineering.
It absolutely does. But that intersection of rugged mechanics and digital tracking leaves us with a really complex question to chew on. We talked about tools deeply integrating with software platforms. Andreas Bayert highlighted the Plera DA3 cordless bolting tool, which now features over-the-air software upgrades, just like a Tesla.
Oh, wow. So the tool's firmware can be updated remotely from the office.
Exactly. But here is the provocative thought. As our physical tool casings and internal gears become practically indestructible, but their functionality becomes entirely reliant on a cloud ecosystem, what happens when a 50-year mechanical tool outlasts its 5-year software support window?
That is a very good question.
Are we rapidly approaching a reality where construction sites and manufacturing floors are going to require their own dedicated IT departments just to manage the firmware patches on a fleet of smart wrenches?
If you enjoyed this episode, new episodes drop every 2 weeks. Also check out our other editions on robotics, smart manufacturing, and industrial AI and digital construction, and with thanks and a reminder to subscribe. Thank you for listening, and remember to subscribe.